Hi everyone, welcome back to Art of the Part. In this video, I'm going to show you how to set up your G54 or your work offset in a CNC machine using a touch probe. Now setting up your G54 or your work offset is very important because we have to tell the machine where the part is located here in 3D space before we start running our G code or our programs. Because we run the risk of that tool coming out and not knowing where this part is and hitting the vise, hitting the table, hitting some other location here in the machine. So again, very important we set up that 000 point in this machine before we start running those programs. So we're going to be using the DMU50 from DMG4 paired with the Siemens 840D controller, as well as a Renishaw Ruby Tip touch probe. And we're going to again touch off in X, Y, and Z. Now what I'm trying to do is find the center location of this assembly here, which is going to be the fidget spinner blank bolted to the soft riser A-1. Now you might be asking yourself, well, why don't I have this clamped here in the vise? Well, I actually like using the 1, 2, 3 block to establish some dimensions in my work offset or my G54, because I know every direction here in X, Y, and Z. It's 1 by 2 by 3, as well as this part is perfectly ground, it's flat, it's made out of steel, so I don't have any high or low points as I measure from one side to the other. This part's made out of aluminum. I'm trusting that these edges are probably really good, they're pretty flat. However, I like to be a little bit more precise using this 1, 2, 3 block, and I also use this in tandem with the work stop, which is another tool that you can use to bolt to the side of your vise. And you can hold or remember a work offset, so every time that I open or close the vise and I put a new part in, I'm not trying to pick up those locations every single time. So if I'm done with this part and then I open up the vise, well, I might clamp it a little to the left, or I might clamp it a little to the right. So having this work stop here and establishing this from a nice flat surface, the machine isn't going to know the difference between a 1, 2, 3 block and this soft riser A-1. So that's why, again, I like using this nice flat surface on the 1, 2, 3 block so that I can establish Z0, and I might not have like a high point or a low point here on a pre-machined part. Likewise, I said that I have already known or predetermined dimensions on this 1, 2, 3 block. So if this height on this part here is 1.21875, and I'm trying to establish this face as my Z0, well, all I have to do is take 1 plus 0.21875 to get to this height, because it's going to sit on the parallels there. Same thing with this side. I have to find the center here. I drew this up in CAD and Mastercam and SolidWorks, and I have a dimension from this flat face here to the center, which is going to be 1.4375. Now, if I wanted to find Y, I would have to actually open up this vise and load this in to get that dimension. However, I would probably touch off on the face of one of these vices rather than trying to touch off on the face of one on this side here. Again, I just run the risk of having some high or low points that could be off a couple tenths, where I'd rather use known ground surfaces that are made from steel. So that said, let's go ahead and start touching off some of these points. I'm going to pull this part out here. I'm going to go ahead and close my door. And I'm going to lock my machine, or lock my door. Alright, so I'm here inside my CNC control. I just want to make sure that I'm in the machine tab. I can also make sure that I'm in jog. Over here in TSM, I'm just going to click on T. And inside of T, I want to load the Renishaw touch probe. And we can see that there's currently nothing in the spindle right now. So I'm going to go to Select Tool on the right-hand side of my soft keys. I'm going to look here in my tool list for the touch probe. I'm going to select OK. And then you just want to make sure before we hit cycle start to pull this out that you don't have anything set to the spindle speed and that you don't have anything set to the spindle direction. We also want to make sure that our pots here for our rapid and our linear are turned all the way up so that I can cycle this tool change so that the tool just doesn't get stuck in midair. So I'm going to go ahead and hit cycle start. This should allow the tool door to open up, and we're going to cycle through the magazine and pull out our Renishaw touch probe there. Okay, So I have my tool out. It's not spinning. That's great because I just want to touch a couple points. I'm going to go ahead and start to locate where I want to input those measurements. So down here on the bottom soft key row, we're going to look for measure workpiece. And in measure workpiece, you can see that it opened up a couple more soft keys. We have touching from one direction, touching two directions. We can actually grab a couple for a circle, so on and so forth. But we're just going to go ahead and click on this touch in one direction. And I'm going to cycle through this and go and find X, Y, and Z. So you can actually pull X, Y, and Z in whatever direction that you want to be pulling from. We have a current work offset. I'll just show you really quickly that if I was in a different work offset, say for example, I was finishing up second operation of the fidget spinner blank, I already have a work offset that was established for that specific piece. So we have X, Y, and Z, and you might be asking yourself, well, hey, shouldn't work offset be G54? Well, not necessarily. So G54 is the first work offset in your memory bank or your library. However, if you go ahead and look inside of your machine offset, go ahead and here see all my tools, but here down below I can see work offset. I can actually see that I have a whole array of different work offsets that are saved in my current library. So I have G54 all the way through G599. Now, it's not going to be all of those numbers. There's going to be a gap, and it's probably going to start at like 501 and then go all the way down to like 599. So you should have something in the realm of like 100 to 150 different work offsets saved inside of your, or work offsets available to save to inside of your control. So you can see here, the G531, that's what I used for the second operation of the fidget spinner blank. Now I want to work into the first operation of the 3-spoke spinner or the 5-spoke spinner. So I'm going to go and click on the G532. I can see that there are no current active values, so that's currently open. So if I go back to my machine, it should bring me back to the work measure piece here. I'm going to measure here in X, and I'm going to change the work offset from, or was actually set to G531, that's what I was showing you, but we can activate G532. So I'm going to activate that G532, and we're going to pull this X dimension from the side of the 1, 2, 3 block, and we're going to touch that point, and then we're going to offset it to the right so that I can locate the center of this assembly here. Okay? So this is a little confusing to think about because we think about like measurements in either like absolute or incremental, but in this case, this position here is going to measure in the positive direction, and I can change this if I'm going from left to right. And if I want to go to the other side, I can change it to negative and then input that, and I can change it going from right to left. You can see the little icon there. However, the way that I think about this specific feature is, am I adding or removing material from that touch point? So in this instance, I'm touching off on this point. I actually want to remove material to get to the center here. So I should, in theory, be opposite of the measure direction. So I have a positive measure direction, and the x0 that I'm trying to establish is actually negative or minus 1.43. So again, that's the known position. I'm trying to remove material to get to the center here. So I'm going to go ahead and apply an x value of 1.4375. Now, before I can go ahead and hit cycle start and pick up that point, the tool is still out there in no man's land. I have to move it from where made the tool change all the way down here to the left hand side of my part. So what I need to do is I need to move this either using the directional keys here on the bottom right and making sure that I'm in jog. However, I think that there's an even easier way to do this, and that's going to be using the hand wheel. So if I click on the hand wheel, it should activate that hand wheel up there. And on the bottom side of my control panel, I'll go ahead and pull my hand wheel out. And again, you're going to have to bear with me. I'm going to use one hand here, but thankfully I have a magnetic surface because I can place this here and I can start moving the spindle while looking at it and operating it here with the hand wheel. So you can see right now that I have a couple pots. So I have X, Y, Z. I have some axis rotations. I also have a feed rate, and that's why I told you that it's important to have this feed rate turned all the way up here, because I want to be able to control it from the hand wheel and not go back and forth and try to find a good balance between those two. So Just want to turn all the way up on my control panel, and then I can go ahead and cycle through this here on the hand wheel. So if I have this currently set to X, and then I have my feed rate set to 0, whatever I do to the hand wheel right now, if I spin this, it's not going to move that spindle. However, if I move the feed rate to say 50, and I start moving this, well, we can see that the spindle is going to move from left to right in X. And I just want to go ahead and position this so that I'm maybe like a ½ inch away from that surface before I take that point. And again, you're going to have to bear with me because I'm just operating this here with one hand. But I'm going to move this down here in Z. Okay. And with the 1, 2, 3 block, you also have to consider that you have a couple holes that you have to avoid. However, I think the risk outweighs the benefit outweighs the risk of hitting those holes because I have a nice ground flat surface. So I need to move this again in X. So I'm going to move this, like I said, like about a ½ inch away. I'm going to move it up in Y. See here, I'm just moving this up in Y. And I'm just going to position myself somewhere here in the middle of one of those two holes, and I'll move myself down a little bit in Z. So I'm going to open up the door and make sure that the probe is in the correct location before I hit cycle start. So I'm going to go ahead and open up this door, open this bad boy up, and you can see I think I did pretty good with one hand. So I'm centered between those two holes and I'm below the surface, so I'm going to pick up this flat face. When I hit cycle start, the probe is going to orientate and then it's going to hit this face and then come back out. So I'll close the door, I'll make sure that this is locked. Before I can actually pick up this dimension, the hand wheel is actually going to override or supersede this command. So you need to turn off your hand wheel. So I'm turning off my hand wheel so it's no longer active. Just going to move this hand wheel out of the way for a minute, and I should be good to go to pick up my first point in X. And I want you to just realize here that we don't have anything recorded here in X, Y, and Z. All those values are currently registering as 0. So as soon as I hit the cycle start, it'll actually measure that point from the home position of the machine. So we might see a crazy number here first. So I'll go ahead and hit cycle start. We'll see that the the probe orientates and then it probes out and touches that point. And it actually measures a value of negative 11.5875. Now, that's all well and good. It's just the last known position of like the home of the machine. However, if I go ahead and hit cycle start once again, I should see this value and this value, this value and this value match. So I'll click cycle start. So we're going to touch that point again. And now we see that this value and this value match. So from that surface, I'm over, so I've removed, in theory, 1.4375 from that plane or from that face. So currently on that work offset, I'm in X, and I'm here, in theory, in like the 3D space of the machine. That's relative, but this is the work offset from the position of the machine itself. So now I'm going to move over here to Z. I'm going to establish my Z offset. And one thing to kind of remember here is in X, I was going positive. However, in Z, I'm coming down. I'm actually going to measure negative. So in theory, I'm actually adding material or removing material. So in this instance, I'm adding material. So I need to be positive 0.2181. So I'm going to go ahead and try and operate this again with one hand. If you do have the permissions, you could change this to position 3 and then have the door open. And you can move the hand wheel as long as the door is unlocked. However, I'm not going to show you that because 1, I can't do it with one hand, and 2, I don't know if you have the permission key to get to level 3 and unlock your machine like that. So I'm just going to pull my hand wheel out again, put it up there, and then I'm going to turn my hand wheel on. And this is why it's important to understand, your X, Y, and Z, your 3D Cartesian planes, because I'm going to retract this out here in Z, and if you didn't know where Z was, you'd be taking a wild guess. You don't want to accidentally hit that ruby tip on the part and actually snap the ruby tip and then have it to get recalibrated and have to buy a new stylus, so on and so forth. So I know I'm going to retract out here in Z, so I'm going to pull this out in Z, And again, I'm just going to locate myself somewhere on the face of my 1, 2, 3 block so I don't hit one of those holes. So I'm going to go over here in X, and I'm going to be about a 1/2 inch above the part. I'm going to try to center this as best as possible. So I'm right about there. And I should be, in theory, able to go ahead and run this. I'm going to move the hand wheel out. I'm going to turn the hand wheel off. And as a good check, I'm just going to open the door, make sure that my probe is located above in the center here on one of these, in a couple of these holes. So that looks pretty good. I should be able to cycle start this and pick up that point for Z. Close the door here. Go ahead and lock that. Got my Z measurement. Again, I typed that in. I am adding, so I'm adding material, 0.21875, to compensate for the total height of my riser assembly with the fidget spinner blank. So I'm good there. Should be able to hit cycle start. So I'm going to hit cycle start, and I'm going to just show you what it looks like here. So I hit cycle start. All right, we touched that point. Z changed from 0 to negative 18.1. That's a pretty large number. And we see a measured value of negative 17. Again, that's in reference to like the home position in 3D space of the machine. So if I measure this once again, and I hit cycle start once again, this number and this number should actually match. So I'll hit cycle start once again. So we touch that face, and we should read 0.2181, or sorry, 0.21875, and then 0.21875. So I think we're pretty good in X and Y. Again, if I wanted, or sorry, in X and Z, if I wanted to set up my Y, I'd actually have to take out my 1, 2, 3 block and place my assembly in there, because the vise is actually going to open a certain distance. However, using that 1, 2, 3 block, I have those nice ground surfaces. I know that I have nice flat faces in X and Z, and then I can find them and offset them using measurements from the assembly that I created. So hopefully that was helpful. I appreciate you watching. I know that this can be a little bit complicated setting up your work offsets, but I cannot stress enough how important it is to create good work offsets to get accurate parts. So thanks for watching, and I'll go ahead and catch you in the next one. Thanks. Bye.